Hi everyone. So today I will be discussing the October 2021 Mechanics Paper 3. So we'll start with question number 1. A particle P is moving in a straight line with simple harmonic motion of period 4 seconds. Okay. So capital T period is 4 seconds. The center of the motion is point O. The center of the SHM is the point O. At time 0, your particle passes through O. Okay. At time t equals 0.5 seconds, P is moving with speed 2 meters per second. Show that the amplitude of the motion is 4 root 2 over 5 meters. Okay. So then you have your SHM. So the center of your SHM is O. So from center to the, now we know the periodic time, if you divide by 4, you get the time taken for each section, right? Because you do realize from the center, this is the corner is the amplitude. So then from the center to the amplitude, you take a quarter of the periodic time. Are you with me? So to travel from the center to the amplitude, you take a quarter of the periodic time. Again, from the amplitude to the center, you take another quarter of the periodic time. I hope you guys can see. So in this case, a quarter of the periodic time is how much? Now you can see capital T is 4 seconds. So if you divide that by 4 to travel from the center to the amplitude, 4 divided by 4, you take only 1 second. Now they are telling here at time 0, the object starts from the point O. So at time 0, the object is here. And then, at time 1 second, the object is supposed to be at the amplitude. So therefore, at time 0.5 seconds, the particle is moving with 2 meters per second. So that means that T equals 0.5. Now, by the way, you cannot assume that in between T and T equals 1, T equals 0.5 will exactly be in the middle. SHM doesn't work like this. This is a variable acceleration, right? So at time equal half second, all you need to decide here is that definitely the object is somewhere between the center and the amplitude. Okay, you can't say it's in the middle, but it's somewhere in between the center and this amplitude. Okay, so I will randomly mark it somewhere over here. We do not know the distance. The distance here is unknown. Distance is measured from the point O. You measure your distance from the point O. The distance traveled is x, and you travel this x meters at within a time of 0.5 seconds. Okay, so that's what they have given you, and they have told you when the particle comes to this particular point, the speed is 2 meters per second. So at this particular point, the speed is 2 meters per second. Are you with me? This is 2 meter per second speed. Okay, so now how do we get this? Show that. How do I get the amplitude? So, amplitude is this length here. How do I get this amplitude? Okay, this full length. How do I get the amplitude? Okay. So what we can do here is, first thing is we'll use the equation for periodic motion. T is equal to 2 pi over omega, right? So this is one of the main equations that we use. Okay, so first, what are the main equations that we use in SHM? T equal 2 pi over omega. The other one is x equals a sine omega t, x equals a cos omega t, and v square equals omega square a square minus x square. So these are the main equations that we use here. We are going to get our answers by using these equations. Okay, so then first we will start with T equal 2 pi over omega, because we know the periodic time. Periodic time is 4 seconds. So then if I apply that here, 4 equals 2 pi over omega, I can get the omega value as 2 pi divided by 4, which is pi over 2. Pi over 2 rads per second. Are you with me? So the omega value is pi over 2. Now what we need to do next is, you do realize your particle starts from the center. Now you have two equations, x equal a sine omega t and x equal a cos omega t. So x equal a sine omega t works when you start your motion at the center, while x equal a cos omega t works if you start your motion from the amplitude, isn't it? These are the theories you learn. So I will go with x equal a sine omega t. So when I use x equals a sine omega t, because at time 0, our particle is at the origin, the x distance we really don't know. So I will say it's x. Amplitude also we don't know. So I'll keep it in terms of, just say it as a sine omega value is pi over 2 into time value is 0.5 seconds or half seconds. Do you agree with me? A sine omega is pi over 2, time is half. So I get here x equals a sine pi over 4. How much is sine pi over 4? So this should be in radian. So sine pi over 4 is sine pi over 4 is sine 45, which is root 2 over 2. Are you with me? So root 2 over 2 a. Okay, is this okay? So this is the x distance. Now we still did not get the answer. We are supposed to find the amplitude. We need to get the value of a. How much is a? We still did not get a. We just got that the x distance at t equals 0.5 seconds. Our particle has traveled a distance of root 2 over 2, root 2 over 2 times a distance from the origin. Okay, that's not what they're asking us to find. We need to get the exact value of a. Okay, so how do I get the exact value of a? So the last step here is, now you can see I got, I came to this point. How do I get the exact value of a? Okay, so once you come to this, what we can do next is, now you know we are going with the equation x equal a sine omega t, since we start at the center. Now they've given you the speed at this point. So you have two approaches to get the a value. There are two methods. The first method is that you can take your equation x equals a sine omega t and differentiate this. Differentiate this with respect to x, because x is the displacement from the center. So if we differentiate displacement, you know, we write it as x dot, or you could say either x dot, or sometimes we write as dx by dt. Okay, so anything is fine, dx by dt, or in other words, x dot, or the velocity when you differentiate displacement, equals a is a constant, sine omega t when you differentiate, it's cos omega t. So into omega t differentiation is omega, because we are differentiating with respect to t. So x becomes dx by dt, a is a constant which says sine omega t differentiation is cos omega t into omega. So dx by dt is the speed, which is 2. So you know, and the speed is 2 meters per second, right? It's given. So amplitude is what we are trying to find. Cos omega value is pi over 2 into t is again half, right? Cos omega is pi over 2, t is half, into again outside you have omega, which is pi over 2. Are you with me? So 2 equals, I'll take the pi over 2 in front with a, pi over 2a times cos pi over 4. Are you guys with me? So then I get here 2 equals pi over 2 into a times cos pi over 4 is root 2 over 2. Am I correct? So actually I don't need this x answer. So you can see I can get the amplitude without even, I don't need to do these steps, right? Anyway, I just did it routinely. So anyway, now you can see I can make a the subject very easily. So 2 into 2 into 2. And I took these two to the other side. Pi into root 2, isn't it? Is that okay? So I get here, yeah, this 2 and 2 goes to the other side. So it becomes 8 over, yeah, pi and root 2 comes down. So simplify, this is 8 over pi into root 2. Okay, so simplify, rationalize, you can multiply, so it's a show that. Yeah, so you can see the root 2, they've rationalized it. So you multiply up and down with the root 2, that gives you 8 root 2 over 2. So 8 root 2 over the 2 makes it 4 root 2 over pi equals to the amplitude. Okay, so this is one way to get the answer. Okay, the other way to get the same answer would be by using v square equal omega square a square minus x square, the other method. Okay, so in the other method, you use v square equal omega square a square minus x square. So v is the speed is 2, so 2 square is 2 square or 4. You can write omega is pi over 2, so pi over 2 square. Shall I immediately write the answer? So pi square, this is going to be pi square over 2 square is 4 into a square minus x square is root 2 over 2a. So when you square it, it's 2 over 4a square. Are you with me? And then again from this equation also, you can make a the subject and end up with getting exactly the same answer. So you don't need to go with both approaches, just going with one is enough. Pi square over 4 times, this is 4 minus 1 minus 2, half is half a square. And then you can make a square the subject, you get here 4 into 4 into 2 over pi square. So 16 times 2, that is 32 pi square. And then you can get the exact same answer. Amplitude is, when you square root, it's 4 root 2, right? 4 root 2 over pi when you square root it. Are you all with me? Okay, so there are two ways to get the same answer. You could go with either method. Just go with one. Okay. So the easiest method here is the one that I did here, rather than going with this, because if you go with this method, it's slightly longer and you need the x value. But if you go with this, where you differentiate x equal a sin omega t, and where you do this question, then you don't need to get the x value. So to get the answer in this manner, we can directly differentiate the x equal a sin omega t and come to this answer in the shortest way. But the other one, the method is slightly longer. Okay. Moving on to part B, they ask you find the maximum speed of P. Okay, how do you get the maximum speed at P? Okay, so maximum speed of P, you do realize to get the maximum speed occurs at the center, right? So it occurs at the center. You can apply V square equal omega square a square minus x square. At the center, x is 0. Okay, so when we at the maximum velocity, the x value will be 0. So apply V square. V max omega square will be, omega is pi over 2, so omega square will be pi square over 4. Amplitude value we just found out, right? How much was the amplitude value? A was 4 root 2 over pi. So amplitude is 4 root 2 over pi. When you square it, how much is it? A square value was 32 over pi square, right? So a square is 32 over pi square minus x square, that's 0. So V square equals pi square over 4 into 32 over pi square. The pi square will cancel out. And then we get here V square equals 32 divided by 4. How much does that give? That's 8, right? So V equals root of 8. That's 2 root 2. 2 root 2 meters per second. Is this clear? Okay, so moving on to question number 2, they say in this question, solutions relying on calculator technology are not acceptable. So, meaning what they what they're trying to tell you here is that you shouldn't perform integrations, like complete integrations, just by typing everything in the calculator. Yeah, so that is what is not allowed here. Okay. So then let's see, a particle P of mass 2 kilogram is moving along the positive x-axis. At time t seconds where t is greater than or equal 0, P is x meters from the origin and is moving away. So it's moving away from O with speed v, where v equals 1 over root 2x plus 1. Okay, the speed is given okay, at time t seconds. Then they say find the magnitude of the resultant force acting on P when its speed is 1 over 3. So when the speed is 1 over 3, what is the resultant force acting? Okay. So normal to get the resultant force, we go with F equal ma, right? So first, before we go with F equals ma, let's get the acceleration. So you can see here we have velocity as a function of displacement. So we will go here with acceleration equals, because I will first go with the acceleration equation. Acceleration equals dv by dt is there, or we have the other one. Acceleration is v dv by dx. So in this situation, because our v is with respect to x, I will go with acceleration equal v dv by dx. Okay. The other equation we use is acceleration equal dv by dt. That's with when it's a function of time. Okay. So now what I'll first do is we'll first get the value of our acceleration. Let's first try to get the acceleration value, and then to get they want the magnitude of the resultant force, right? So just get the force. All you have to do is apply F equal ma, multiply the mass with the acceleration value, and you have the magnitude of the resultant force. Okay. Okay. So acceleration equal v is given. Can you see here? V is 1 over root 2x plus 1. And dv by dx. Okay. So dv by dx, we can actually find dv by dx by differentiating this. Are you with me? So shall we get dv by dx here? So V equals 1 over root 2x plus 1. So to differentiate this, shall I first bring it up? 2x plus 1. When you bring it up, it's 2x plus 1 to the power minus half. Are you with me? It's 2x plus 1 to the power minus half. So now we'll differentiate and get dv by dx. So dv by dx equals, first you bring the power in front, minus half. 2x plus 1 to the power minus half minus 1 is minus 3 over 2 into 2x differentiation is 2. Are you with me? Minus half 2x plus 1 to the power, you subtract 1 from the power and then into the inside differentiation of 2x plus 1, that is 2. So dv by dx, minus half and 2 cancels to give minus 2x plus 1 to the power minus 3 over 2. Are you with me? And then what do they want us to do? Okay, so the next thing we do is we have the dv by dx value, we have the v value. So now we need to get the, let's calculate the acceleration, shall we? So acceleration equals v dv by dx. Okay, so v is 1 over root 2x plus 1 times dv by dx is minus 2x plus 1 to the power minus 3 over 2. Are you with me? So then I think you can see we get some kind of a function for acceleration that is in terms of x. So you get the acceleration function completely in terms of x. So if you can get the x value here, you can substitute the x value into this equation and actually get the acceleration answer. So what I'll do here is we do have the x value, right? They have given us, they have given the speed here. They have given the speed is 1 over 3. So you can replace the speed v value as 1 over 3 and actually get the respective x value. So v is 1 over 3 equals 1 over root 2x plus 1. Root 2x plus 1 comes as a multiplication equals the 3 goes as a multiplication, 3 into 1. Do you agree with me? 1 times root 2x plus 1 equals 3 times 1. Now remove the root by squaring both sides. 2x plus 1 equals 9. So x equals 9 minus 1, 8. 8 divided by 2, x is 4. Do you agree? So when the speed is 1 over 3 meters per second, the respective x value is 4. So now what you can do is replace the x value 4 and get the acceleration at that specific point, because you have to get the acceleration when the speed is 1 over 3. When the speed is 1 over 3, x is 4. So when x equals 4, now you replace x equals 4. How much is the acceleration? Can you all send me the answer? 1 over here. 2 times 4 plus 1 minus 2 times 4 plus 1 to the power minus 3 over 2. So I get here 1 over 2 times 4 is 8 plus 1 root 9, that is 3 into minus, this is again 9 to the power minus 3 over 2. How much is the answer? So the acceleration is, yeah. So acceleration will be, yes, minus 1 over 81. Right, minus 1 over 81. So now all we need here, this negative mark is because, you know, acceleration is always directed towards the center. So, so all you have to do here is now we just need to find the magnitude. Okay, so we need the magnitude. So you can remove the negative sign, because the negative sign just gives the direction, an idea about the direction of the acceleration, because these equations are used away from the origin. Okay. So acceleration is always directed towards the origin. That's how simple harmonic motion works, isn't it? So anyway, if you want to get the magnitude of acceleration, magnitude is simply 1 over 81. Okay, and then the magnitude of the acceleration is just 1 over 81, the size of the acceleration. And then the force, the resultant force will be mass into acceleration. Mass is 2 kilogram into acceleration 1 over 81. So resultant force is 2 over 81 newtons. Okay, 2 over 81 newtons. Is this clear? So part B, they say when t equals 0, p is at O. That means at time 0, particle is at the origin, and that means x is 0 when you are at the origin. Find the value of t when p is 7.5 meters from O. Okay. So how do we do this one? Now, the thing is to input. Now, the problem here is we don't have, now if you look at the acceleration equation that I just created, everything is with respect to x here. So how do I create a t inside this particular question? Because we need to input time now. So normally the way we introduce time into these kinds of displacement question is by using the velocity. So we do know velocity is what? Velocity is dx by dt, isn't it? Right? This is 1 over root 2x plus 1, and then you can replace the velocity as dx by dt, because we know velocity is dx by dt. There's only one equation that we use for velocity, v equals dx by dt. So after you come to this point, now it's time to separate variables. So you can bring the 2x root 2x plus 1 here. With respect to x, and on the other side you multiply 1 with dt. Can you see what's going on? Root 2x plus 1 with dx and 1 times dt, and then you integrate both the sides. So this side you integrate with respect to x, the other side you integrate with respect to t. So this is basically separating variables. Okay, so when you integrate root 2x plus 1, you know, this is 2x plus 1 to the power half. So when you integrate ax plus b to the power n, so this is basic P4 integration, sorry, P3, basic P3 integration. So how does that work? First you bring the power in front, so 2x plus 1 to the power half, how does that work? Integration of ax plus b to the power n, how did that work? It was 1 over ax plus b to the power n plus 1 divide by n plus 1, right? Yeah, this is the way. So the coefficient here, divide by the coefficient of x. So x coefficient is 2, so 1 over 2. 2x plus 1 to the power half plus 1 is 3 over 2. Divide by 3 over 2 equals, okay, is this clear? Equals integration of 1 with respect to t is t. And don't forget the plus c. So when you simplify that half and this 2 cancels, and you have 1 over 3 times 2x plus 1 to the power 3 over 2 equals t plus c. And now to get the value, now they are asking you to find the value of the time when p is 7.5 meter from O is x is 7.5. However, we can't directly do that. First, we have to get the c value. How do we get the c value? They have told you at time 0, particle p is at the origin, means at time 0, x is 0. So substitute at time 0, x is 0, get the c value. 1 over 3 into 2 times 0 is 0 plus 1 to the power 3 over 2. P is 0 plus c. How much is c? 1 over 3 into 1 to the power 3 over 2. 1 to the power of anything is 1, which means c is 1 over 3. This gives me the final equation for, so substitute the c value back into this equation. What do we get? This gives me, sorry, not that one. We will substitute it to this simplified version, right? This one. So when you substitute, I get here 1 over 3 2x plus 1 to the power 3 over 2 equals t plus c is 1 over 3. Are you with me? So now what you need to do here is replace the, find the t value when x is 7.5. So when x value is 7.5, what is t? So when x is 7.5, get the t value. 1 over 3 into 2 times 7.5 plus 1 to the power 3 over 2 equals t plus 1 over 3. Get the answer? (15 plus 1), that's 16 to the power 3 over 2 minus 1 over 3. Am I correct? This is correct. So 1 over 3 into 16 to the power 3 over 2 minus 1 over 3. The answer is 21. T is equal to 21. Can you see? T equals 21 seconds. Okay, are you guys okay with this? Question number 3. A particle P of mass m is attached to one end of a light elastic spring of natural length L. Okay. So a particle of mass m is attached to end of a light elastic spring of natural length L. Can you see what's happening? You have the particle m which is lying on top of the elastic spring. And modulus of elasticity kmg, where k is a constant. The other end of the spring is fixed to the horizontal ground, as you can see in the figure. The particle P rests in equilibrium with the spring vertical at the point E. So this point E is where it is resting. Now, when it comes to this resting point, can you realize what has happened here? The spring has a natural length of L, 1L, right? So obviously you can see, because with the weight of your particle, it has moved slightly down. It has moved slightly down, right? There's a slight displacement downwards. So then with that weight, now it's in the equilibrium position. Point E is where the spring is in equilibrium. Okay, the particle P rests in equilibrium. At the point E is at a height 3/5L above the ground, as shown in figure 1. Show that K equals 5/2. So normally what is the process we do here? So you can see there's a compression here because we have the natural length here, right? So normally natural length is L. Now here they have given the natural length is L. So this length here is L. Okay. Then how much of a distance has the particle displaced? So you can see L minus 3/5L, the distance it has displaced from the natural length. This is 2/5L. So if you mark all the forces acting at the equilibrium position, okay, what are the forces? Number 1 is you have the weight of the particle. The weight of the particle, mg. And then what else do we have? We also have, now you can see the object is staying in this position with mg. The opposing force is the thrust produced by the string, isn't it? The pushing force. So the spring will produce a thrust or a pushing force to balance this out, isn't it? Okay, so in this case, because the spring is being compressed, the spring will produce a thrust, not a tension. Okay, because the spring is being compressed. So now what you can do here is you can apply for part A, T equals mg at the equilibrium position. So tension equals lambda x over L. By Hooke's law, tension is lambda x over L. Mass is m and into g. Then lambda value is given to us as kmg, right? The elasticity lambda is kmg into x is the amount it has displaced. So you do realize the displaced amount is 2L/5. Divide by, I'll say into 1/L. This 1/L is this L that was down here. I have written it as 1/L. Okay. So lambda value is the kmg here. And x is the x is the amount that you have displaced, or the amount the spring is compressed. Okay, so it has compressed or it has gone down for distance 2/5L. The distance, the difference between the natural. Okay, so this is equal to mg. Okay, so lambda is kmg. Extend the compression here is 12/5 into 1/L. Okay, the denominator, that's the natural length. Natural length is directly L equals mg. So you can cut L to L here, and then we get here k 2kmg over 5 equals to mg. So you can cancel off m and g, and you can get here k is 5/2. 5 goes up, 2 comes down. So k is 5/2. Do you agree with me? K is 5/2. And then they say in the next part, okay, so part B, they say particle P is now moved a distance 1/4L vertically downwards from E. So from this point, point E is the equilibrium position. So from the equilibrium position, they are moving it a distance of 1/4L, a further distance of 1/4L vertically downwards from E and release from rest. Air resistance is modeled as being negligible. Show that P moves with SHM. Okay, so how does this work? Okay, so now I have drawn a series of diagrams here. This is for the natural length, the particle with the weight of the particle. the object is in equilibrium at 3/5L. And then from that point, they are further bringing it down distance 1/4L from its equilibrium position. So this is really important that you realize what this particular distance is, because if you bring a system that is in equilibrium, now this is a SHM system, and in this system, when you compress this object a further 1/4L meters down from its equilibrium position, that particular distance is going to be your amplitude, because that's the distance that you have compressed from the equilibrium position. So you release, it immediately starts to move in SHM with an amplitude of 1/4L. Okay. So then to prove that the object moves in SHM, all you have to do here is get the forces acting on the particle at a general point. So get the forces acting on this particle at a general point. So this is the center. Okay, so a point E is the center of your SHM. So from the center, normally we say the distance travel from the center. This is the X distance. So the distance traveled from the center is X. And then what are the forces we have? So obviously, you know, you have the weight and the thrust here, isn't it? So weight downward, the weight is mg. And you know, you have thrust here because this is being pushed upwards. You have thrust T. Are you with me? So remember here, this X is now this X that I use here. This is the distance that you are away from the center of your simple harmonic motion. So remember, E is the center of SHM. That is extremely important. The equilibrium position is always the center of your SHM, and whatever the distance you displace away from the equilibrium position, that amount will be the amplitude. Okay, so then to show that the object moves with SHM, you have to show an equation of the type x double dot equals minus omega square times x. So to get that, to show that equation, we need to apply F equals ma at a general position, not at the center, not at the amplitude, but at a general place. So I'm going to apply F equals ma in this general diagram here. So let's apply. So F equals ma, and I'm going to apply it in the same direction that I applied x. Okay, F equals ma. So what are the forces that are acting here? So downwards I have mg minus upwards I have thrust. So mg minus thrust, those are the only two forces here, equals mass. Mass is m, right, into acceleration is x double dot. So the whole point of to prove it moves with SHM is you have to get an equation of the type x double dot equals minus omega square times x. So this is what you have to prove. You have to get an equation that is in this particular format. So mg minus t, tension is lambda x over L, right? So what about the tension here? Shall we find the tension? So who is tension? Tension is lambda x over L, but in here now you need to input the values. Lambda value was kmg. Lambda value was kmg. We found the k value. I'll put kmg here for now. Lambda value is kmg. What about the x value? Now, when it comes to the tension in the thrust in this particular spring, and when it comes to the distance x, what does it mean by the letter x here? What does it mean? Does it mean this x distance that you have moved over here? In the tension equation, lambda x over L, the x is the difference between the natural length and wherever you are right now. The amount displaced, the difference between the natural length and wherever you are. So remember, your natural length is L. So your natural length is L. How much have you displaced here? So you know this particular distance, now the natural length is L. You have displaced already 2/5L when you were in the equilibrium position. Okay, so this was being compressed 2/5L to come to the equilibrium position, and then at this general point, it has further gone down in a distance of x meters. So here x is the amount of compression that the spring has gone through. So spring is naturally over here. So remember, this x here is not the distance away from the center of your SHM. Okay, so in the tension equation, x is the distance or the compression of your spring. Okay. So then let's get the answer. Okay, so it's really important that you identify what this x here represents. Okay, it's not the x distance that I used over here. X is the compression of the spring. When you use Hooke's law. Okay. So kmg into the x distance. How much have we compressed? The total compression of the spring is 2 over 5L plus x plus the displacement from the center. Divide by natural length L. So shall I put 1 over L here? The natural length L. I'll just write as 1 over L because I want to use k value. Now k is 2 over 5, right? Sorry, k was 5 over 2. So let's input the k value. Equals 5 over 2 mg into 2 over 5L plus x into 1 over L. So I'll put the L down here with 2. Is that okay? I'll put the 2 down here with the 5. So 5 divided by 2L into mg times 2 over 5L plus x. Okay, so this is how I use the tension. Are you with me? Shall we substitute everything? So mg minus the tension value is 5 over 2L times mg into 2 over 5L plus x equals mx double dot. Okay. So let's simplify. Mg, open the bracket, minus 5 over 2L into 2L over 5. It cancels off. And you get, can you see? 5 over 2L into 2L over 5. That cancels off. And you remain is simply mg. Can you see? You remain with simply mg, and then minus 5 over 12 mg into x is 5 over 12 mgx equals mx double dot. The minus mg plus mg will cancel out. And then minus 5 over 12 mgx equals mx double dot. The m will cancel out. And then you get the equation for x double dot. Do not go to replace g as 9.8 by any chance. So keep it in this format. X double dot equals minus 5g over 2L times x. So can you see that we have got the equation? X double dot equal minus omega square x. So you can see here the omega square is 5g over 12. Do not replace the G value as 9.8 because wherever you do that, you are supposed to give the answer to 2SF or 3SF. So the omega square value here, by looking at this, omega square is 5G over 12. Or in other words, the omega is root 5G over 12. Okay, so this is the omega value. Okay. Okay, and then once you get the x double dot equation, you should give the conclusion. Therefore, object moves in SHM. Therefore, SHM. Okay, so just give the conclusion. Okay. Let's go for the last part. Sorry, part C. Find the speed of P as it passes through E. Okay, so you have to find the speed of the particle when it passes through E. So this is quite not as complicated as the other part, because if you understand what's going on here, you know E is the center of your SHM. So if E is the center of your SHM, you know in simple harmonic motion, the maximum velocity, the maximum V max occurs at the center. So in the velocity in the part C, so when you are trying to find the velocity at the at point E, find the speed of the particle at E, right? Find the speed of P as it passes through E. So all you have to do here is use V square equal omega square A square minus X square. And in here, now in this equation, remember for SHM equations, okay, V square equal omega square A square minus X square is a simple harmonic motion equation. In a simple harmonic motion equation, X represents the distance you are displaced away from the center of your SHM. Okay. So make sure you use the x value correctly here. So V square, so at the center, or at E, at point E, you know the x value should be 0, isn't it? X value is 0. So let's substitute everything. V square equal omega square value was 5G over 12. 5G over 12. Amplitude is So I just told you that the amount you displace from the center is the amplitude, right? So from the equilibrium position, they have displaced the object distance of 1 over 4L. So amplitude square will be 1 over 16L square, because amplitude is 1 over 4L. Amplitude is 1 over 4L. So when you take it, it's 1 over 16L square minus x square is 0, because when you add the center, x is 0. Simplify, v square equals 5g, and L will cancel out, right? You have an L cancelling out here. 5g L over 16 times 2 is 32. Do you agree? So V equals to root 5g L over 32. Are you with me? So maybe you could simplify this slightly. Okay, you could simplify this slightly by doing root 5 over 32. Okay, so we can't type GL here. GL will definitely be inside the root. So this is root 10 over 8. So V equals root 10 over 8, which means the root 10 GL, everything will be inside the root, and 8 is outside. So root 10 GL over 32, because the root 10 was inside the root, the G and L also, you know, they're inside the root. So root 10 GL over 32. Okay, you could leave the answer in any equivalent form. It's correct as long as it's an equivalent format of these answers. It will be that will be fine. Okay, last part. They say find the time from the instant P is released to the first time it passes through E. Okay, so what does that mean? When it's released, you know, you release at the amplitude. From the time you release until you pass through E. So from the amplitude to the center. So I think I was explaining this in the first question also. The time taken to go from the amplitude to the center is a quarter of your periodic time, isn't it? The time taken to go from the amplitude to the center of SHM is a quarter of your periodic time. That's a basic theory. Okay, so let's get the periodic time. Periodic time is 2 pi over omega. 2 pi over omega was root 5g over 2L. So we simplify, this is 2 pi times root, the 2L comes down, 5g goes up, basic simplification, right? Denominator, 2L will come up, 5g is in the denominator, and you get this is the periodic time. So you need to get the time to the instant where P is released until it first passes through E. So the time that we require here is 1 over 40. So 1/4 of the periodic time. So that gives me the answer pi over 2 2L over 5g. Pi over 2 times root 2L over 5g. Is this clear? Okay, so this is the answer. Okay, so now we will move to question number 4 in October 2021 M3. The question number 4 says a light elastic string has natural length 2a and modulus of elasticity 2 mg. One end of the elastic string is attached to a fixed point O. A particle P of mass half m is attached to the other end of the string. Okay, so you can picture what's going on here, right? The point A. Okay, so this is point O, and you have your string. It's attached at point O, and they say there is a point A which is vertically below O with OA 4A. So there is this point A. So from O to A, the distance is 4A. Okay. Okay, now what do they say here? Particle P is held at A. So you take your particle P to point A and you're releasing it from rest. Okay, so you take the particle from O, the original length, the natural length is 2A, and then you bring it down to point A. Okay, natural length is 2A. Okay, so natural length is 2A. Okay, and then you bring it down to the length of the point A where the distance is 4A, And they say, what do they say? The particle P is held at A and released from rest. So you're releasing it from rest. The speed of P at the instant when it has moved a distance A upwards. So when this has moved a distance A upwards, okay, so at that point, the speed is how much? When it has moved a distance A upwards, they say the speed is √3 ag. Okay, this speed is √3 ag. And they are saying air resistance to the motion of P is modeled as having magnitude kmg, where k is a constant. Using the model and the work energy principle, they ask you to use the work energy principle. Show that k equals 1/4, so it's 7 marks. Okay, so you need to realize it's 7 marks. So there is a lot of working to do here, and they want you to use the work energy principle. Now, normally work energy principle we use for work done against friction is equal to change in energy, right? That is what we normally apply. So now in here, you can see in this system, there's no friction here. We are not moving on a surface. So what is the resistive force here? The resistive force that you are modeling here is the air resistance. So if they want to use work energy principle, then the only way we can go here is work done against what? Work done against air resistance. So work done against air resistance is equal to change in energy. So change in energy means, you know, when you have a system where you have a friction, a resistive force, the initial energy is higher than the final. So initial energy minus the final energy. Okay, so whatever the initial energy, you have to subtract with the final energy. Okay, so then what do we have for the initial energy? So at point A, so at the point A, what are the energies that we have? They say the particle is released from rest. There's no kinetic energy, and you can see the elastic string has been stretched, right? Which means we have what? At A, we have elastic potential energy. So shall we find the initial elastic potential energy? So let's get the initial. I will find these separately because it's easier. Initial elastic potential energy equation is lambda x square over 2L, isn't it? Okay, the equation is lambda x square over 2L. So lambda value, modulus of elasticity is given to you as 2mg in the question. So lambda is 2mg. What about the x? X is the length that your string is stretched beyond its natural length. So natural length is 2a. You have stretched at point A. It has one distance 4a, which means it has stretched a distance 2a. 4a minus 2a. So you have stretched 2a. So lambda into 2a square divided by 2 times natural length is 2a. So simplify and let's get the answer. I can cancel off a 2 here. And I get here 4mga square, right? 4mga square divided by 2a. Do you agree? So I can simplify this slightly and it gives me, yeah, the 4 and 2 cancels, 2mga. I get 2mga. Okay, and then let's go for the next part. So what's the next energy? So initially I have elastic potential energy, and then you can see we have the particle is moving up, which means we have a GPE gain, isn't it? So we have a GPE gain, and we also have a what? Kinetic energy also, there's a gain, isn't it? Let's get those values. So kinetic energy gain is half mv square, because we initially start at 0. So half mass was, what was the mass? The mass was not m. The particle piece mass is half m. So half, the mass is half m. I hope you guys are clear with that. This mass is not m. Mass is half m. And then the v square, what is the v value? Velocity is √3 ag, which means when you square it, it's just 3 ag. So when you simplify, I get here 3 over 4 mga. 3 over 4 mag, mga. So, and then what about the potential energy gain? So at the bottom, you know, we can see that it's a potential energy 0 level. So how much has it gained in potential energy? mgh. M is, mass is half m. Okay, so mass is half m. Be really cautious about that. Mass is half m. G and height is a. You know, you are moving a distance a upwards. So you get here half mga. And what else do we have? At the end, we also have the final elastic potential energy, right? Because at this point, have they given a name to the point? They say the speed of the, okay, they have not given any name. Okay, so anyway, when you come to this particular point, we have to get the elastic potential energy. So again, elastic potential energy is lambda x square over 2L. Lambda value is 2 mg. What about the extension? When you come to this point over here, how much has the string stretched? Now you are over here. Then from here to here, you can see natural length is 2a. So if you are at this point, how much what is the distance between O to the place where the particle is? It's 3a, right? Because you have traveled 1a up. So it's 3a, which means the extension is 3a minus 2a. This length is 1a. The extension is 1a. So lambda extension is a. So a square over 2 times natural length is 2a. Agreed? Okay, so when you simplify, I get here, the 2 cancels out. I get half mga. A also cancels out. So I get half mga. Do you agree with me? Okay, so initial, so I think I have all the energies done here, sorted out. And all I have to do is now to apply this equation, work done against air resistance equals initial energy minus final. Okay, so let's input those values. Okay, so work done against air resistance. How do we get the work done against any force? Work done against any force is force into distance. So what they have told you here, the air resistive force, right? How much is it? They have told you the air resistive force is kmg. So kmg, and how much of a distance are you moving against air resistance? A. You move this distance A. Can you see? You move this distance A against air resistance. So it's kmg times A. Initial energy, what do we consider for initial energy? At the start, I told you we have only initial elastic potential energy. There's no kinetic energy. There's no potential energy at this point. So initial energy is, what do we write here? The initial elastic potential energy, 2 mga. And subtracting with the final energy, what do we have for the final energies here? We have the kinetic energy gain, because at this point, when you come up, you have a kinetic energy gain, you have a potential energy gain, and you have the elastic potential energy again. So it's the kinetic energy gain 3 over 4 mga plus half mga plus again the final elastic potential energy is half mga. Can you see the values are used here? Kinetic energy, potential energy, final EPE. So all these 3 values at the final energy. And then you simplify and what? Make K the subject. So in this equation, now you can see M and G is common to everyone. Actually, MGA is common to everyone. MGA is common to everyone. So K equals 2 minus, I'm opening the bracket with a negative, 2 minus 3 over 4 minus half. So type everything in the calculator. How much do you get for K? K equals 1 over 4. Okay. Okay, so now moving on to part B. They say particle P is now held at O and released from rest. As P moves downward, it reaches its maximum speed as it passes through the point B. Find the distance OB. Okay, so what are they doing? They are taking the particle to the top here, to the top, the point O, and they are releasing it from rest. Okay, so you're releasing it from rest, and they say as P moves downwards, it reaches its maximum speed as it passes through the point B. Okay, so we don't know where point B is, but this is the maximum speed occurs at point B, and your task is to find the distance OB. So how do we find the distance OB? Okay, so now if you now you can see it's just 4 marks here. Okay, so you might be thinking now normally when it comes to maximum speed, we know if it's in a simple harmonic motion, the maximum speed occurs at the center of SHM. But in this particular question, because we use work energy principle, we do not know where that where the center is, right? So then, in that case, what we'll do here is for maximum speed, we do realize at the maximum speed, we know that the acceleration will be 0, right? At the maximum speed. So what you need to do is considering along this path. Okay, so you need to find at the position where the maximum speed is occurring, the acceleration is 0. So if the acceleration is 0 at that particular point in the path, when the acceleration is 0, what happens? When you reach to your maximum velocity, now you know this particle is released, so it comes racing down. Okay, so you come to this place where you have the maximum speed. Okay, so when you come to this maximum speed position, you know the acceleration will be 0, x double dot, or the acceleration is 0, which means what? At that particular point, at that particular instant, the forces acting on this particle will be in balance, isn't it? Because at that point, the acceleration is 0, which means the forces acting at that point, at that instant will be in balance. So this is O, this is the point B. Let's mark all the forces acting on this particle. First one we have is the tension. Okay, next what do we have? We have the weight of the particle. So they have said the mass is half m, which means the weight is half mg. Is that all? So normally when we do questions, we normally mark the tension and the weight. But you know, in this question, they very clearly mention about the air resistance. So if this object is from O, you are releasing and it comes down, you realize the air resistance should be opposing the direction, which means we have the air resistance acting upwards. So at this point, when you reach the maximum velocity, the forces are acting on around this particle must be in balance. Okay, so what you can make an equation here. What is it? The half mg, the weight is equal to the resistive force plus the tension. So weight half mg equals to resistive force. Resistive force is kmg. K value is found. K value was found as 1/4. Do you agree? K value is R value. Resistive force is kmg. K is found as 1/4. So let's get the answer here. Half mg minus 1/4 mg is equal to tension. Okay, so now what we'll do is let's use the tension equation. Half minus 1/4 is 1/4, right? 1/4 mg equal tension. Tension is lambda x over L. Okay. Okay, so then the tension is given as lambda x over L, right? Normally by using Hooke's law. So then at this point, at the point B where the forces are balanced, lambda is of course 2 mg, right? The lambda value is given, the modulus of velocity is 2 mg. Let's input the values. And what about the extension? So this extension is actually, now you know the natural length is 2a, right? The natural length is 2a. So I will keep the extension as x because this is the unknown. Okay, at the end of the day, I have to get the OB length. Okay, so extension, I will keep it as x. X is the amount that it has stretched beyond the natural length 2a. Okay, so this extension, I'll keep it as x divided by natural length L is 2a. Do you agree with me? So I can cancel off 2. And what else? We can also cancel out mg. So we can get here x equals 1/4 and the a can come up over here. So 1/4 times a. Can you see? So x equals 1/4 into a. And then what we do is they ask you to get the distance OB. So how do you get the distance OB? So the extension here is 1/4a, but the distance OB is the natural length plus this x. So OB distance equals the natural length plus 1/4a. How much is it then? 9/4a. So this is the length of OB. Okay, so if you try to do this by using the work energy principle, so it will be very difficult. Okay, so because you really don't know the, it will be quite challenging. Okay, so the best way to do this is when they say the maximum speed, the acceleration is 0, and at that point the forces are balanced, and then go ahead with this rule. So this is the easiest way to get it done. Okay, so moving on to question number 5. They say a small smooth ring of mass m is threaded onto a thin smooth fixed vertical pole. Okay, one end of a light inextensible string of length 2L is attached to point A on the pole. The other end of the string is attached to point R. A particle P of mass m is attached to the midpoint of the string. The particle P moves with a constant angular speed in a horizontal circle with both halves of the string taut, and AR equals 6L/5 as shown in figure 2. It may be assumed that in this motion, the string does not wrap itself around the pole and that at any instant, the triangle APR lies in a vertical plane. show that the tension in the lower half of the string is 5 mg over 3. Okay, so you need to realize what the picture and what the first thing is. Anyway, you have to mark all the forces acting on this, right? So they say here show the tension in the lower half of the string. So in this part of the string. So what are the forces we have? First, let's apply the forces acting on the particle. So what are the forces we have? Definitely, we have tension acting at the upper part. So you need to realize that when you attach a particle like this, we create what? Are we creating the same tension on both sides of the string, or do we create different tensions? We create different tension. You get the same tension only if it's passing through a ring. Okay, or if it's a bead and you have threaded it so that the string goes through the bead, then the tensions are equal. But in this case, because you're attaching a particle, the two halves of the string will be separately considered. So I will say this is tension A and tension R. Okay, tension A and tension R for these two sides. Okay. And then of course at A you have fixed it onto the wall, but at this point here there's something interesting. Why? Because at this point, can you see that you have fixed it to a ring here? So there's a ring that's here, right? The ring has a mass. The ring itself has a mass. How much? The ring has a mass of mg. So how will this ring be in equilibrium? Because you know this ring has a tendency to go up the pole, right? Or because if the speed increases, it can go down or it can go up. Okay, it could go either direction. So how is it kept in balance? Why? How would this ring be kept in balance? Because this is a smooth ring, right? So it can slide along this pole. So how do you keep it in balance? Obviously, the tension component, because you can see tension R, you can write it over here also, right? And can you see you can take a tension component upwards here. And then thereby you can manage this. We can have a vertical equilibrium here to keep this ring in place here. Okay, so because the ring can slide up or down, but we know this is in equilibrium. So we need these forces to be in balance. Also, if there's a ring, you need to know that there should be a normal reaction here as well. Okay, so anyway, we will not be needing to use the normal reaction. Okay, so you can just mark normal reaction anyway. Okay, so how does it work now? Okay, I need to get the tension in the string. So how do I get the tension in the string? Okay, so first thing is we'll need to find an angle. Okay, so shall we find the angle? Okay, how can I get an angle? Let me mark this angle as theta. Okay, how do I get this angle theta? So you know this is an isosceles triangle, L and L on either side, right? So this length is L. How much will be the other side, this particular length? Because it is exactly in the middle, isn't it? So this should be 3 over 5L. So I can get the value of which theta? So I have here this is the 90 degrees. So I have the hypotenuse and I have the adjacent. So which means I can go for cos theta. Do you agree? So cos theta is adjacent over hypotenuse 3 over 5L divided by L, which gives me cos theta as 3 over 5. So this is a pretty common ratio that we use, right? 3 over 5 for cos. And then because immediately when you know cos theta is 3 over 5, you can write the sin theta ratio as well. Do you agree with me? What's the sin theta ratio? If cos is 3 over 5, then sin theta should be, you know, you can like make a quick right angle triangle here, cos square adjacent over hypotenuse. So by Pythagoras theorem, the other side should be 4. Okay, so it's a pretty common one that we use in M1 and M2. So this is in M3. Sin theta will be 4 over 5. Okay, so we have that. So now let's go for the equilibrium. Okay, so let's go for the equilibrium. How do we go with the equilibrium? Tension R, right? So I need to get the tension in the lower part of the string. So I can go consider the forces acting on whom? I can consider the forces acting on the ring. Okay, acting on the ring, and I can go for so taking the ring alone. Only the ring. I will take only the system of the ring, and we will go for what equilibrium? We will go for vertical equilibrium in the ring. Okay, so considering vertical equilibrium of ring. Considering vertical equilibrium of R, because you can see using it on the particle P will not help you, because of particle P there are two tensions, so we can't work with it. So vertical equilibrium of ring, what do we get here? Tension R cos theta, right? Tension R cos theta is equal to mg. Are you with me? Tension R cos theta is equal to mg. So tension R cos theta is 3 over 5 equals mg. So tension R is, tension in the lower part of the string is 5 mg over 3. Do you agree? Okay, so considering the vertical equilibrium. But here my R direction is wrong, isn't it? Why? This is not necessary actually. But you can see normally for horizontal equilibrium, the tension R sine theta should be in balance with R, right? So anyway, they are not asking you anything about the normal reaction, but so if you take the horizontal equilibrium of the ring, then tension R sine theta should be equal to this normal reaction. Okay. So we don't need that. Okay. Then the next thing we need to do here is, okay, so that's not necessary. All we need to do here is to find the tension in the lower part of the string. So just 3 marks. This is more than enough. This is all you need to do here. Okay, just you need to have a proper understanding of what's going on here. Okay, then the next part they say for 8 marks. Okay, they tell you find in terms of L and G the time for P to complete one revolution. Okay, how do we take the time to complete one revolution? Normally, the time taken for one revolution, we use the equation T equal 2 pi over omega. This is the time taken for one revolution. So basically, in other words, for 8 marks, what do we need to do? We had to find the value of our omega, right? We had to find the value of our omega. Okay, how do we find the omega value? Okay, so fine. So how do we get the omega value? So normally when it comes to horizontal equilibrium, there are only two things to do. I have told you all. In a horizontal circular motion, there are only two things to do. Vertical equilibrium is number one, and the other one is applying F equal ma towards the center. So if you consider all the forces now in this situation, consider all the forces acting on particle P. Okay, so in particle P, we have the tension at A, we have the tension at the lower half of the string R, and also I have to mark here what? We also have the weight, right? So it did not affect part A. I had not marked it for part A, but it didn't affect part A because in part A, I was working on the ring. I was only considering the ring system. So ring system is a separate system. So now what I'm doing is I'm considering all the forces acting simply on this particle P. Okay, so only the particle P system is considered here. Okay, considering all the forces acting on particle P, because particle P is the one that is going through this horizontal circular motion. So what you do here is you apply vertical equilibrium for particle P and you apply F equal ma towards the center. Okay, so let's mark all the forces. You need to kind of resolve this, right, to apply vertical equilibrium. So how do we mark the angle? So first thing is I notice that I can use alternate angle, and do you see the theta comes here? Because we need to resolve this R, so the theta comes here with alternate angles. The next thing is you do realize that this angle that I marked here, this is 90 minus theta, isn't it? So this is 90 minus theta, and okay. So what about this? What about the other side angle? How do I get the value of the other angles? Yeah, so what we can do here is you do realize you have an isosceles triangle here, isn't it? So if it's an isosceles triangle, the angles at the base of the isosceles triangle are equal. So this theta comes up over here. Do you agree with me? Why? Because these two lengths are equal. So this is an isosceles triangle. The base angles are equal. So if this becomes theta, then what happens? So by using the alternate angles, you can again take the theta over here. Do you agree with me? This theta comes over here through alternate angles. Okay. So now I'm ready to resolve. I'm ready to work with it. So let's go for vertical equilibrium of P. So vertical equilibrium. So how do we get the vertical equilibrium? How does it work? So you can see here tension A. Okay, let me mark it again. There is the tension A. Okay, so tension A cos theta is acting upwards, isn't it? Tension A cos theta. Okay, it balances out with whom? You have the mg, the weight, mg weight, and what about tension R? Tension R also resolves downwards to give you tension R cos theta. Do you agree? Tension A cos theta, the vertical component is equal downwards. You have mg and tension R cos theta, the vertical component. Okay, so how does it work? Tension A is unknown. Cos theta is known as 3 over 5, we just found it, equals mg plus tension R value we found in part A, it's 5 over 3 mg. 5 over 3 mg into cos theta is again 3 over 5. Okay, let's get everything together. Tension A times 3 over 5 equals mg. 5 over 3 into 3 over 5 will give me mg, right? Because it cancels out. Do you agree? So TA into 3 over 5 is equal to mg plus mg. That's 2 mg. So tension A is 5 multiplies it to 10 over 3 mg. Do you agree? Tension A is 10 over 3 mg. Okay, so now what do we do after you apply vertical equilibrium? Now you apply F equal ma towards the center. So apply F equal ma towards the center. What are the forces acting towards the center? What are the forces you have towards the center? The tension A, you get a component for the center. Tension R, you get a component for the center. Mg, the weight is vertical. So therefore, you don't get a horizontal component from that. You only get the components from the two tensions. So we get here tension A, which one? Cos or sine. So if you're going towards horizontally, tension A sine theta. And from tension R also, you can get a sine theta. Tension A sine theta plus tension R sine theta. So I will apply F equal ma towards center. So the center is in this direction. So tension A, sorry, not cos theta, it was sine theta, right? And tension R sine theta. Do you agree with me? Tension A sine theta, tension R sine theta towards the center. The other forces don't come, mg doesn't come. So remember, we are only applying forces on P. Okay, so only the system, the forces acting on P are considered here. Okay, so equals to what? Mass is M. Acceleration, what do we use for centripetal acceleration? So for centripetal acceleration, we can use R omega square. We have V square over R and R omega square. So since I'm trying to find omega, we will go with R omega square, where R represents the radius of your circular motion. Okay. So TA, TR are both known. Sine theta is also known. The only thing is the radius. What is the radius of this horizontal circular motion? Can you all tell me what is the radius of this horizontal circular motion? This is L. Yeah, so you can, if you consider this particular triangle, yeah, how does it resolve? The L resolves to give you L sine theta. Can you see that? So this will be L, the distance will be L sine theta. Do you agree? This distance. Okay, so you resolve this L cos theta is the vertical length here. L sine theta is the horizontal length. So L sine theta will be your radius. Okay, so then let's input the value. Tension A. So radius is L sine theta. I'll keep it here. We'll apply it now. So tension A is 10 over 3 mg sine theta. Tension R was how much? 5 over 3 mg, right? 5 over 3 mg, that is tension R, and that is sine theta, equals mass is M, radius is L sine theta into what? Omega square. So omega is what we're trying to find. Now in every equation, I think I can see M is common. M is common, and also sine theta is also common. So we can get rid of both of them. So I get here 10 over 3g plus 5 over 3g equals L omega square. Do you agree? So 10 over 3 plus 5 over 3, when we add, we get 15 over 3, which is 5g. So 5g equals L omega square, which gives me omega square is 5g divided by L. Omega square is 5g divided by L. So omega will be, take the positive root, omega is 5g over L. And now we can go for the periodic time. Time taken for one complete revolution is 2 pi over omega. So 2 pi over root 5g over L. So you can rewrite it as keeping 2 pi out. The denominator you have 5g and L you have again as a division. So L can come up. 5g comes down, and you can write like this: 2 pi times root L over 5g. You agree that this can be written in this manner, right? The denominator is denominator. You can take it up, and the 5g is in the denominator. So inside the root, it happens inside the root. So this is your periodic time, the time taken for one complete revolution. Okay, is this clear? Okay, moving on to question number 6. A light rod of length A is free to rotate in a vertical plane about a horizontal axis through one end O. A particle P of mass M is attached to the other end of the rod. The particle P is held at rest with the rod making an angle alpha with the upward vertical through O, where tan alpha is 3/4. So the moment you see tan alpha 3/4, you can immediately write down what? You could immediately write down the cos alpha value and the sin alpha value. Can I know what's the cos alpha and sin alpha? Tan alpha 3/4 is adjacent over opposite over adjacent, right? Tan alpha opposite is 3, adjacent is 4. How much is the hypotenuse? By Pythagoras, it is 5. So your cos alpha will be adjacent over hypotenuse and sin alpha will be opposite over adjacent. Okay. Then they tell you here, the particle P is then projected with speed u in a direction which is perpendicular to the rod at the instant when the rod makes an angle theta with the upward vertical through O. The speed of P is v as shown in figure 3. Show that, okay, you have to get this, show that v square equal u square. So look at the variables in the show that you have v, you have u, you have a, you have g, and you have cos theta. Okay, so obviously when it comes to, you know what this question type is, first of all, right? This is vertical horizontal motion, right? So we did the horizontal circular motion earlier. Now it's vertical, it's vertical circular motion. Okay, so it's vertical circular motion. So in this, there are two concepts we apply. What are they? Conservation of energy and F equal ma towards the center. Those are the main principles we apply in this particular for vertical circular motion. Okay, so then what do we do here? Let's apply the law of conservation of energy, because you don't have any loss in energy. We go with the law of conservation of energy. So what's the initial energy we have here? So shall I consider my GP 0 level as O? You can consider GP 0 level at any point you wish. Okay, you could take it at any point you wish. So I just took it from O. Okay, so if you're above O, you have a height above, means you have a positive GP. If you are below, then you get a negative GP because your height is below. Okay, so at the point P, what are the energies we have? At point P, I have half m u square, isn't it? Kinetic energy half m u square. Have they given us the mass? No, right? So I use the mass. Yeah, mass is m. Particle P of mass m, half m u square. Yeah, initial energy equals final energy. That's what we do here. That's the law of conservation of energy. So initially I have kinetic energy plus what's the potential energy here? Can I know the height of this guy? How much is this height? This is A. Yeah, so you can see this alpha is over here as well, right? So this length is A, the length of the rod. So this is A cos alpha. Do you agree? So then I can write here mgh is A cos alpha. Great. Okay, so that's those are the two energies I have at point P. Okay, so then let's when you move an angle theta, okay, what are the energies we have? So here I have half mv square because the velocity is v. And what about the mgh? How much is the height now above the ground? How do you get this height? So again, you can see this length is a, right? And you can see this angle theta. You can take the letter z and the angle theta comes over here. Can you see? Can you see the theta comes here? This theta comes here because of letters the alternate angles. Okay, so this theta comes over here. So then this height will be how much? A cos theta. Do you agree? It becomes A cos theta. So mgh is A cos theta. Agreed? Okay, so now simplify and get the show that I can see m is common to everyone. So shall I cut off the m? M is common to everyone. Okay, let's substitute the values. Half u square plus GA cos alpha is 4/5. Do you agree? Cos alpha is 4/5 equals half v square plus GA cos theta. Cos theta is a part of your answer. And if you look at the show that v square, u square is independently there. So I will multiply this entire equation by 2 to get rid of the half. The equation I'll multiply by 2 to get rid of the half. So half into u square is u square. This becomes 4 GA over 5 multiplied by 2 is 8 over 5 GA. Half into 2 is just v square. This is 2 GA cos theta. So when I make v square the subject here, I get v square equals u square plus 8GA over 5 minus 2GA cos theta. Okay, so then we need to get the show that here. So we need to simplify. And then we take the common denominator. Now you can see here u square is there alone. So I'll take these two guys together, take the common denominator with 5. Is that okay? So when you take the common denominator with 5 for these two, it's this is 8GA. Here, of course, I'll multiply by 5, right? So when you multiply by 5, you get minus 10 GA cos theta equals v square. So now you can take we can take what out? We can take 2AG out and the 5 common denominator. I can bring it down over here. Okay, so 2 times 4 is 8. The GA goes out. 2 times 5 is 10. GA goes out and you have cos theta remaining and you get the answer for v square, which is our show that for 4 marks. So make sure you show all the relevant steps to get the method marks because it's a show that you must show the relevant steps, the relevant working to get all the marks. Okay, is this clear? Okay, then we'll move to the next part. Okay, so they have told you it is given that u square equals 6AG over 5 and P moves in complete vertical circles. So complete vertical circles means this is capable of coming back to the top again and passing, right? So it moves in complete vertical circles. When theta equals beta, the force exerted on P by the rod is 0. Okay, find the value of cos beta. Okay. So when theta equals beta, the force exerted on P, okay, by the rod is 0. Okay, what do you mean by that? Okay, so then, so when you're moving in complete vertical circles, you know, if it's a rod, what's the requirement to move in a complete vertical circle in a rod? Yeah. Okay, so normally we say that at the highest point, normally for to go in a complete vertical circle, the velocity should be greater than 0, isn't it? So anyway, in here, now they tell you here that now they're talking here about the force exerted on P by the rod is 0. So what is the force exerted on this particle by the rod? Okay, let me erase all this thing. Let's consider the, so here this theta is a general position. So what is the force exerted on the particle by the rod? Obviously, that is a tension here. Okay, so what we'll do here is first let's apply. Now I already applied the law of conservation of energy. So the remaining rule that we need to apply here is the law of, we apply F equal ma towards the center for circular motion. So apply F equal ma towards the center at the general point. Okay, at the place where theta, where the value, where the angle with the vertical is theta, because theta is a general angle. Okay, so at this point, at this general point, we will apply F equal ma towards the center and get the answer in terms of theta. And then they have told you here when theta is equal to beta, then the force exerted by on P by the rod is 0. So the force exerted on P by the rod is, what are the forces we have here? Let's talk about the forces and then say which one is 0. What are the forces here? We have the weight, right? We have the weight of the particle, that is mg. What else do we have? You have the tension here, isn't it? The tension, so here, okay, so this tension, it can be, yeah, so then this is the force exerted on the rod by P, right? So this is the force. So this is what you should make into, this is what you should make equal to 0. Okay, so first what we'll do is let's apply F equal ma towards the center first. Okay. You have to resolve mg because the mg component will also act towards the center, right? Okay, so let's take here part B. So let's apply F equal ma towards center. So when you apply F equal ma towards center, what do we get? Directly you have the tension, and then you get the mg cos theta. Do you agree with me? There's an mg component acting towards the center. Tension plus mg cos theta equals m. The acceleration we normally put r omega square or v square over r. Which one is the more appropriate one here? V square over r is the more appropriate one, because here we want to work with the v square. So v square over r means radius is a. Do you agree? Okay, and then what you need to do here is, they have told you when theta equals to beta, what happens? The force exerted on P by the rod is 0. So this force exerted on P by the rod is this P value. So T will be equal to 0. Are you with me? Yeah. So make it equal to 0. So I get here 0 plus mg cos beta equals mv square over a. And I think we got already in part A, we got the equation for v square, the general equation for v square. Can you see? So we can substitute the v square equation over here, shall we? Mg cos beta. Shall I take the a over here? We could keep a there. Equals m over a times, who is v square? Who is v square? V square is u square plus 2ag over 5 times 4 minus 5 cos beta. I replace the theta with beta, because now theta is equal to beta. Okay, and you need to make what? Cos beta the subject in this equation. That's all they want you to find the value of cos beta. So m, shall I directly cut off the m here, because this m is outside of this entire bracket. I'll cut off the m. Then I get here, I'll take the a also here, ga cos beta. Do you agree with me? I took the a to the other side. So I get here ga cos beta equals u square. Here there's this bracket is now free to open, 2ag over 5 times. Yeah, so we'll open, right? Shall we directly open? 2 over 5 into 4 is 8ag over 5. And then, yeah, 2 over 5 into 5 is, the 5 will cancel, right? 2 over 5 into 5 is minus 2. Minus 2ag cos beta. Do you agree with me? Now take the cos betas to one side. Ga cos beta minus 2ag cos beta. If you bring it here, Ga plus 2Ga cos beta, that's 3Ga cos beta equals, u square value was given to you. U square is 6Ag over 5 plus 8Ag over 5. Again, you can see Ag is common to everyone. So remove 3 cos beta equals, can you all add 6 over 5 plus 8 over 5? How much is it? 14 over 5. So this gives me cos beta equals 14 over 15. So this is the value of cos beta. Okay, so this is all you have to do for 6 marks. You need to realize when the force exerted is 0 means the tension, you have to make it equal to 0 at the general point. At theta equal beta, you make the tension 0 and you get the answer. Okay, is this clear? Okay, question number 7. They say a uniform solid right circular cone C with vertex V has base radius R and height H. Show that the center of mass of C is 3 over 4 H from V. Okay, so it's 4 marks. So these are theories you learn in the M3 book. Am I correct? So how do you create a cone? Now, obviously, in M3, when you come to this 3D object, we create the 3D object by using where we rotate the curve 360 degree around the x-axis. That's how we create all the objects, right? So then, how do we create a cone? How what is the way? What is the way that we can use to create the cone? I mean, what do we use? So the cone, what we can do here is, can you see this straight line? Obviously, it's a straight line that we revolve around the x-axis to create the cone, isn't it? So this straight line, okay, if you rotate this 360 degree around the x-axis, do you agree that it comes like this? You get this shape, and then you have this circular face at this end. Can you see? So then they have told you that this particular length is R, right? This is the radius of the cylinder of your cone, and this length is the height. Do you agree? Okay, so then how do we get the center of mass? Now the center of mass is obtained by what? By rotating the original equation was this particular line. So I'll draw it, I'll highlight it. So this is the original line, this line. We revolved it 360 degrees around the x-axis to create the cone. Okay, so what is the equation we use in 3D objects? So you learn an equation in your form in your textbook, right? So what's the equation to get x bar? Because you can see this object is fully symmetric around the x-axis. You don't need a y bar here, right? You only need to find the x distance from the vertex here. So x bar equal, what was the equation? Integration x y square dx over y square dx, isn't it? This is the equation that we use. Am I correct? Okay. So then to use this equation, first of all, you need to know the what is y here, the equation of the line. Basically, this is the line that we use. So you have to know what this equation is. Y equals to what? So this is what kind of a, I mean, you can see it's a straight line. It's not a curve. So how do you write the equation of the straight line? Y equal mx plus c, right? So this is a straight line that passes through the origin. So what is the gradient? Can I know the gradient of this particular line? Y equal mx plus c. So what's the equation? So can you see here the gradient is actually, you can take it from as r of h. Gradient is r of h. Directly, yeah. So y equal mx. So r over h times x. So that is the original equation that you revolve around the x-axis to create this cone. So y equal r over h x. So these are theories you have done. You don't have time to think of this thing in the exam. You need to quickly do it and go. Okay, and then what about the limits? What are your x limits? We starting where x value? Starting x value is 0, ending x value is? What is the ending x value here? Yeah? The x value is h, right? This distance is h along the x-axis. So here starting value is 0, ending x value is h. So your limits will be from 0 to h. Are you with me? Okay, let's integrate each part separately. So I will integrate xy square dx first from 0 to h. So integration x y square will be, y is r over hs. So y square will be r over hx whole thing square. Do you agree? Okay, let's simplify, get the answer. So I get here x times. Do you agree r and h are constants and they can be taken out? R square over h square into x square, right? So I get here r square over h square out x, and this x is a square here, isn't it? So x square with x, when you multiply directly, I'll write here as x cube. Is that okay? So now let's integrate. So r square over h square, when you integrate x cube, you get x to the power 4 over 4, and your limits are from 0 to h. Okay, then let's input the values. R square over h square. So when you input the value, I get here h to the power 4 over 4 minus 0. Obviously 0 to the power 4 over 4, that's 0. So when you simplify, what do we get here? So when I simplify, I get here r square h square over 4. Okay, are you with me? And then the other part, integration y square dx from 0 to h. Y is r over h times x, so we square it. So I'll take r square over h square out, integration of x square with respect to x. The limits are from 0 to h. So r square over h square, this is x cube over 3, and your limits are from r square over h square. So when you substitute, it's h cube over 3 minus 0. So when you simplify, it's r square h divided by 3. Okay, so time to substitute these values into the equation and get the x bar. Integration xy square dx over integration y square dx. So xy square was r square h square over 4 divided by r square h over 4 over 3, sorry. So I think very clearly you can see the r square will cancel out. So what else is remaining? H square over 4 into 3 over h. If I write like this, do you agree? 3 comes up, the h stays at the bottom. And then when you simplify, it's 3h over 4, which is our show that. Okay, this was a show that they wanted us to do. Show that the center of mass of C is 3 over 4h from V. Yeah, so it's 3h over 4. Okay, so then we'll move to the next part. Okay, so next part they tell you a solid F shown below in figure 4 is formed by removing the solid right circular cone C dash from C, where cone C dash has height 1 over 3h. Can you see what they're doing? So from the original cone, they're removing the top part of the cone, right? From the large cone, you remove a smaller cone. And this is show that the center of mass of F from its larger plane face. So from the larger plane face, they want to show the center of mass is 3 over 13 h. Okay, how do we do this? So what is the theory here? So we'll go for object mass, center of mass. Object mass, center of mass. So what's the first object we consider here? The large cone. Mass is obviously, for mass, we take the mass proportional to the volume. So what's the volume? Volume of the cone is 1 over 3 pi r square h. Are there any substitutions to do here? Yeah, you can put a row, the oils, yeah, just the mass, yeah, it's enough. Okay, so 1 over 3 pi r square h. Mass is proportional to volume, and r and h are correct, yeah. So radius is r, height is h. And center of mass, they say they want it measured from the larger plane face, right? So shall I take it from the larger plane face then? Shall I take the O as this point? So if it's O at that point, can I know the center of mass of this cone? So just a moment ago, we found the center of mass is 3 over 4h from the vertex. So which means from the plane face, it should be, this is 1h. So 3 over 4h from vertex means from the other end, it should be 1 over 4h. Okay, so that's the first object. Now go for the second one. Yeah, so the second one, we go for the smaller cone. The cone that we remove. Okay, so what? So they tell you that they are removing a cone of what? Height 1 over 3h. So height is 1 over 3h. What about the radius? Yeah, so the radius will be, as you can see here, these you can consider these as two similar triangles here, right? Can you see? Okay, so inside the cone, so you're removing this part, right? So this is h over 3. So basically these two triangles are similar. Can you see? Okay, so they're similar triangles. So if this is h over 3, when this is h, so then we have to have the same ratios. If this is r, then this also should be r over 3, because the ratios must be similar. You can make it and see, but in here it's not necessary. Okay, so if it was a 2r, then you have to be, you have to just maybe cautious. So here, because it's r directly, this should be r over 3. Okay, radius is r over 3. Okay, and then remember your O is somewhere else. Okay. Remember, now we are breaking, this point is over here. You are taking the center of mass. O is a little bit ahead. Okay. Let's get the mass. Mass is 1 over 3 pi r square. What is r square? R is r over 3. 1 over 3 pi r square. H is also h over 3. When you simplify, what do I get? I get here, this is 1 over, yeah, 3 into 3 square into 3 is 81 pi r square h. Do you agree? 1 over 81 pi r square h. Okay, and then the other guy, the center of mass. Now be cautious, the center of mass we are measuring from O. Okay, remember, with the center of mass we measure from O. So this remaining distance was 2 over 3h, right? Isn't it? This remaining distance is 2 over 3h. Then from the origin, or from the plane face, the center of mass of the cone is 1/4 of its height, right? You remember 3/4 of the height from the vertex, so 1/4 of height from the plane face. So 1/4 of this particular height. 1/4 of what is the height here? 1/4 of the height of this cone is 1/3h, or h over 3. So remember that gives you the center of mass of distance from the plane face. Is that the distance I want here? No, I want it measured from the origin. So from the origin means I have to add 2/3h. Do you agree? Because I'm giving the center of mass from the O here, the 2/3h plus the 1/4 of this h, 1/4 of this cone's height. Do you agree? Can I know the answer here? Simplified answer. H over 12 plus 2h over 3. How much is it? How much? 3h over 4. Do you agree? Okay, then the last one. Last one is where we remove, right? Last one is where we remove. So can I know the mass difference? Obviously, you have to subtract 1/3 pi r square. You have to subtract with 1/81 pi r square. Let me take pi r square out. 1/3 minus 1/81. How much is it? How much? So 26/81 pi r square. And what about the center of mass? So that's what we are trying to find. Okay, so we are ready with the table now. Now it's time to apply, take mass into center of mass and get the answer. So let's multiply. So remember, from the large cone, you are removing the small cone. I put a minus sign to remind us that we are supposed to remove. From the large cone, we remove the small cone and we get this frustum shape. Okay. Okay, so let's multiply. How does it work? 1/3 pi r square h multiplying with 1/4h. Then it's not addition, it's a subtraction. 1/81 pi r square h into 3h over 4. Agree? Equals to total mass 26/81 pi r square h into x bar. Do you agree? Okay, and then you can cut off the common things. So for everyone, pi r square h is common. Can you see there are 3 terms? Pi r square h is common to everyone. Can I know the answer here? 1/3 into 1/4 is 1/12h minus 1/81 into 3/4 is 1/81 into 3/4 is 1/108. H equals 26/81 into x bar. Can I know the subtraction? 1/12 minus 1/108. How much is it? So 2/27h. Shall I bring the 26 and 81 to the other side? 81 comes up, 26 comes down. Do you agree? So 2/27. Okay, so 2/27 into 81/26. Do you get the show that? 3/13. This is the show that, right? Three over 13h. Agreed? So this is the show that. Okay, let's go. Okay. Okay, so moving on to the last part, they say the solid F rests in equilibrium with its curved surface in contact with the horizontal plane. So this solid F, okay, it rests in equilibrium with its curved surface. Have you seen this? The curved surface, you're keeping it on a horizontal plane. Show that 13r square is less than or equal 17h square for this to be in equilibrium. So I think I might have discussed this in a previous paper as well. I think I gave the, yes, where you learn where when you keep the object where it can turn back again. Yeah, so let me explain. So I think I gave the theory to you in a previous paper also. Okay, so how does it work? Now you keep this piece, you keep this on the surface, right? So then you, when you keep this curved surface on here, you end up creating something like this, right? So this is what you create, right? Can you see? So then there were very specific requirements to keep this in equilibrium. Okay, so let's draw the axis of symmetry here. So this is the full cone if it were there. Okay, so I drew the axis of symmetry. So they say you that now they keep this solid F in with its curved surface, and they say it's in equilibrium. So if it is in equilibrium, you have to show that this condition is satisfied. Are you with me? Okay, so what is the requirement? Now, right now we found that the center of mass is at a distance 3/13 h from the where? From the larger surface, right? From the larger plane face. Okay. So what is the requirement for this to be in equilibrium? Do you remember me talking to you about this? Now, you know, if this might, the problem is whether this will turn back or now we require this to stay in equilibrium, not turn back. So do you remember how we mark the forces in this specific question? So at this last end, okay, at this very last end, you mark the normal reaction. Isn't it? Are you with me? So you mark this normal reaction here. And the thing is, it's not the normal reaction. It's just that the fact that this is the critical point. So let me name this as point X. So if your center of mass, okay, if your G is after this point, you can see your G can go down and it can meet with the, it can meet with this surface, right? So in that case, this object will be in equilibrium. Yes, why? Because when your center of mass is acting over in this area, the weight can go down and it can meet, I mean, the line of action of the weight can meet the surface, which means the normal reaction will act at that point. But what happens if your weight is acting over here after this X? Over here, what if your weight is somewhere over here? So can you see when you mark the weight, can the line of action of the weight meet with the can we have the normal reaction occurring from this point? No, isn't it? It's a normal reaction and the weight component. Now, when there are two forces in equilibrium, you need to realize that those two forces should be on the same line to be in equilibrium. Otherwise, there will be a moment. So that's what happens if you have the center of mass G. If it's over at this point, the normal reaction will come to the very last point, and G over here, it will create a moment, and this will turn front. So it will not be in equilibrium. So in order for this object to be in equilibrium, okay, so this is not the normal reaction. Just I'll draw this dotted line here. Okay, so all that's required here is, okay, all that's required here is this point X. So this point X is the special point here. Okay, the G should be after. Your G should be after point X. Are you with me? In that case, the object will be in equilibrium because the weight and the normal reaction can act on the same line. Because if the G acts like this, then normal reaction will act on the same line upwards like this. They are on the same line. The weight and G can act on the same line. While if the G goes to the other side behind X, the normal reaction and G will not act on the same line. Do you agree? Because normal reaction can only act when there's a touch at that point. Okay, so now what we need to do is to get this, show that. Okay, let me mark this point G here. Okay, so I have to get these distances. Okay, I need to get this distance. How do I do that? How do I do that? Let me mark some extra information here. Okay, so I will name this vertex. This was the vertex V, right? Are you with me? Okay, so this is the vertex V. Did we know the angle of this particular cone? No, right? Okay, so let me, let me take the vertex as V, and now let's write the requirement to be in equilibrium. To be in equilibrium, if you talk about the distances, what is the requirement? The distance VG, can you see V to G distance, should be what? The VG distance should be greater than or equal to the VX distance. Do you agree with me? It needs to be greater. The V to G distance should be greater than or equal to Vx. It can even be on top of X, but a VG should be greater than or equal to Vx, so that G will, the weight and normal reaction can act on the same line over here. So this is the requirement to be in equilibrium, and if you can now successfully find the VG and Vx distances, you should be able to get this, show that. Okay, how do I get these distances? Okay, let me mark this. Now I know that this is, how much was this height? This was, what was the part we removed? We removed 1 over 3h, right? And this radius was 1 over 3r. So I'll say this angle is alpha. Okay, I'll say this angle is alpha. Okay, so we don't need to even go with B. We can even mark a point at this, at the smaller plane face and also do it. Okay, so now what? Okay, so this height is 1 over 3h, the cone that you remove. This height is 1 over 3r, right? So we found that the height and radius of the cone that we removed was 1 over 3h and 1 over 3r. Do you agree with me? Okay, let me take this point as C. Shall I name it as C or give some W? Okay, you all want W, right? You said you want to name it W. Just give it any name, okay? Just the letter name, because I want to give these distances. So what we need to do here is, okay, you can even write to be in equilibrium without going Vg is greater than or equal Vx. You could even write what? The Wx distance can be what? Sorry, the Wg distance should be greater than or equal Wx. Even that is okay, because otherwise for Vg, I have to get this 1 over 3h also I have to add. Okay, so we can go with Wx, Wg distance must be higher than W2x. That means the center of mass from the smaller plane face to G, that distance must be higher than this point X. Now point X, how do I mark? This point X is a special point because that I drew this from the very edge of the from the very edge here. The last place where the normal reaction can act. So that is the critical place, and I drew the vertical line over here and I marked this point X on the axis of symmetry. Okay, so now what I want to do is I want to get the WG distance and WX distance. So WG distance is not an issue, right? Because at the other side I marked O, and OG distance we found. What was the OG distance? The center of mass was how much? OG distance was, we found it as 3 over 13h. And also we know that this distance is 2 over 3h, right? So is it difficult to get the WG length now? If this is the whole thing is 2 over 3h, this is 3 over 13h. How much is WG? What is the WG length? How do I get that length? From 2 over 3h, I subtract the 3 over 13h. Do you agree? So 2 over 3 minus 3 over 13 is 17 over 39. 17 over 39h. Do you agree? Okay, and then the other one, now I got the WG distance. Now to get WX. So WX is a little bit of a challenge. So let me show you how it's done. Okay, so I think for WX, what I'll do is I will be using the help of the cone that I removed also. Okay, look at how it's done. I made this quite large. So I have marked the angle alpha here, the angle at the vertex of the cone. So do you agree if I write like this? What is tan alpha if you consider this small triangle here? Tan alpha is opposite over adjacent. Do you agree? So opposite is 1 over 3h. 1 over 3r divided by 1 over 3h. How much is it at the end? 1 over 3, 1 over 3 cancels. You get r over h. Do you agree? And then also, do you see that you have 90 degree here? And this is going to be 90 minus alpha. Which means also, do you see that vertical and horizontal here is a 90? Can you see that? So that this horizontal and this vertical is a 90, which means this angle here again is what? This small angle here is again a alpha. Do you see what I'm talking about? This small angle here is again an alpha, this same alpha. Are you with me? Can you understand how I mark the alpha in this small angle here? Because this angle alpha, this is 90 minus alpha, which means this is the horizontal, and I told you this is the vertical, the last place where the normal reaction acts. So these two are making a 90 here, which means if this small angle is 90 minus alpha, the other one has to be alpha. Can you write tan alpha by using this small triangle as well? So you can see you have this small triangle, right angle triangle over here. Can you see? Can you write tan alpha for that triangle as well? How do you write it? Tan alpha equals opposite over adjacent. Opposite is the wx. What we need. We are trying to find wx, right? Opposite over adjacent is what? You can see this is the 90 over here, right? So who is the adjacent here? This is the opposite. This is the 90 here. This is the adjacent. Don't we know this length? 1 over 3r. It's 1 over 3r. I hope you guys can understand what I'm doing here. I use this angle alpha into here. To this point. Okay, there's another right angle, the small right angle triangle concerning wx. Okay, so then opposite is wx, adjacent is 1 over 3r. So tan alpha value, now we know it, right? Tan alpha value is r over h. Do you agree with me? And I can find wx now. So tan alpha is r over h equals wx over 1 over 3r. So multiply wx equals r over h into 1 over 3r. So what do you get here? 1 over 3r, I brought it immediately as a multiplication. What do I get? R square over 3h is equal to wx. Do you agree? So wx will be equal to r square over 3h. Children, do you agree? Okay, so I have the wx distance, I have the wg distance. Now it's time to apply it into this. We don't need to go with vg and vx because otherwise you have to add 1 over 3h to both of them again. That's not necessary, right? So wg is 17 over 39h. Do you agree? Is greater than or equal. Wx is r square over 3h. So now cross multiply and let's get the answer. 17h into 3h greater than or equal r square into 39. Are you with me? So 17h into h is h square. I think I can see 39 and 3 I can divide. Shall I divide the 39 and 3? So I get here 17h square greater than or equal 13r square. Is this to show that 13r square is less than or equal 17h square? So that's what I got here, right? Just that the two sides I have written the other side. 13r square has the mouth closed towards it. See here also I have 13r square, mouth is closed towards it. So I could write 13r square, mouth is closed towards it, 17h square, mouth is open towards 17h square. So I have not done any difference. Okay, I really hope you understood this part. I explained this in a previous video as well. This part is a little bit tricky. Okay, but if you can understand how to take the distances, then if you can understand, then you can get the show that's quite easily. Okay. Okay, so this is the end of the October 2021 M3 paper.